Welcome everyone to a new lesson in remote sensing techniques, or more or less using ArcGIS for this purpose. Today I would like to show you some small introduction into ArcGIS, how to use it, how to import raster data, and also how to manipulate raster data in ArcGIS. And we will concentrate therefore on the ArcGIS version 10, especially on the Service Pack 1 edition, due to the fact that the first build of ArcGIS 10 has a lot of failures in it, especially in the projections. Therefore we will start ArcGIS. There we go, and it's more or less ArcMap and the version number 10. And as you can see, I have a very customized view on it, so I would like to explain you some details. First of all, you will be presented with this getting started dialog, and therefore you will more or less see no recent projects. In my case I have 4 of them, so we will use a new template, something called a blank map. And don't forget there's a second dialog on the screen, especially on the lowercase here, the default geodatabase for this map. What does it mean? So if you're doing some kind of calculations for your raster or some kind of savings, it can be stored in this default geodatabase, so you can adjust it like here. So I'm not very pleased with that. Some find it very easy to understand. I'm more or less this old-fashioned guy who has a special folder, something called a work directory or something like that, and I would like to store my data in it. But if you have a lot of data, and especially if you would like to use it in ArcGIS server or any other ArcGIS application, you should get to know these kind of geodatabase. So we will start with a blank map. Just press OK, and so there's a lot of things you can see in this screen here. So let me just arrange some things. You will probably see this blank view over here. This is a so-called data view. You can see it in this small scaled button here, and then you have a section called table of contents, where you can where you will have an overlook over your layers which you have imported in your data. And there's also something called arctoolbox. These are the tools you can use on your data sets like raster data, geodatabases, tables, shapefiles, whatever. And you can also adjust the dialog over here. So this is the ArcToolbox window which will open. Just press it and you will have your tools available for the moment. If you have a complete version of it containing also the Arc catalog, which is very expensive, you can also get access to that on this right case. And as you can see, it is opening automatically, so I'm not pressing any button here, and you can adjust the visibility by just press auto hide here, and so it won't disappear anymore. So yeah, we will just close it for the moment, and we will concentrate on the data view, and especially in that, getting your data into the view. So what we are having here are a lot of tools available. I will go into detail in some moments or some minutes or maybe some sessions. What is the most important in that is that you can see here something called add data, and we will start with adding data, and after that I will go into some details like the layers and the projections and everything like that. So please mark beforehand that on the lowercase here you can see that there's no projection available, so there's no metrics in it in your data view, so you don't know whether these are meters, miles, or whatever, because there's no data available. So we will add some data in a moment. I've downloaded some ETM plus data from landcover.org, and also a topographic data set called SRTM, and we will start by adding maybe this layer. So this is a tiff file. you can just select datasets and layers, and he will find all available data in your folder. So we will use that, and just press add, and that's it. Something you have to know beforehand is that you can, if you're selecting some data, you have these folder connections. Normally you can just select data from your personal geodatabase, which I have explained in the first moments. So you have to make a folder connection to that. So therefore just go to the folder connections, and you can adjust or create a new folder connection by using this button, connect to folder. This is probably some kind of disturbing in the moment, so just make sure that you have some kind of working directory or special directory where you are storing, or where you will store all your results, raster data, and all your geo data. So just make folder connections like that, choose your folder, press OK, everything is fine. So I've done this beforehand, so I have now the folder connection to my desktop, and in this folder connection I have the ArcGIS tutorial folder. So I'm using that one. Now I can choose my layer and press OK. And what you can see now at the moment is that you are having some more information in your data view. So you have a metric now, and you know something about the projection. It's not much, but you know that you're measuring in meters here. So we will go into our in our layer, just make the right button, click the right button, and use properties. For ArcGIS, it's very important to know that the right button will be your friend in that program. This is such a deep structured program. You can get into I think something like the 10th layer of your dialogues here, something like that. So please make sure you're using the right button if you're not aware, or if you don't know what to do. There's some kind of disturbing, but you will see it, especially in a video I've made called Making Maps with ArcMap or with ArcGIS. You can see some of that right-clicking adventures over there. So we are now having the layer properties in this case. So you see some kind of tabs here. So we have the general, what is the layer name. This will be important by making maps afterwards. You can select the scale range, how far you can zoom in and zoom out on this data view, and it depends whether you would like to see this layer in a certain scale. So if you're far away from the layer, shall it still be shown on the data view, or shall it not? So you have a source, and this is the most important in it at all. So you have some kind of properties like the number of columns and rows, the number of bands, the cell size, which is approximately 30 meters in that case. You will also have something like the extent, and which is the importance, or the most important at all, is the spatial reference. So you can see now that we are having here something like a UTM system. We have a linear unit of 1 meter, and you can see the zone here, which is the zone 48 north. There's no statistics available for that layer, and that's it. So this is the most important at all. Okay, we'll click it now, and now we'll go into some details for viewing your layer and arranging your data view. So you're now having a total zoom in it, so you will see the full extent of the view, which is this button here. So if you're going too detailed like this, you can just press on the full zoom or the full extent button, and you will see the total area of your data. So if you're having here a lot of layers in it, it will concentrate the zoom on all of them. So we'll go into details, and as you can see here, we have some kind of problem. There's much gray in it. Probably you know why. look at the scale of it, so you have the lowest possible value in this layer is minus 32,000 something, and the highest is 32,000 something. That depends on the the bit system behind the layer. So we'll go into the properties once again, and as you can see here, you have a pixel depth of 16 bit, not bit. What a mistake. Sorry for that. So 16-bit. What does it mean? So you have the highest possible value is 32,000, and the lowest is minus 32,000 in that pixel depth. Normally these ETM plus data will be presented in an 8-bit system, so you have values ranging from 0 up to 255. This is not the case, so if you're dividing this possible scale or color scheme here into upper and the lower part, the part between 0 and 255 is more or less gray. So this layer has a lot of gray in it. And oh no, that was a wrong case. So going back, so you have some kind of undo, add layers, and redo functions in it here as well. I will concentrate more on the view now. So you also have a fixed zoom in. As you can see here, there are some scales automatically chosen, and you can use that one. And there's also go back to the previous extent. So if you're doing some kind of strange things like that, just seeing here 1 pixel, you can go into you can go back to the prior state of your view, and then you have a select elements button. This is not useful just by using raster data, and which is quite important is the identify buttons. So if you're not sure what is a value you can see here, you can also have a look more or less, or mostly the case, into the MET file. In this MET file, this is MET file for this special scene. So you have Landsat surface reflectance, and it is provided by the global land cover facility, and so there you have a processing date, a product version, and as you can see, normally the Landsat data is presented in radiation. So you have a value of 0, which means no radiation, or more or less it is a bounding box of the scene. Then you have 1, which is no radiation, and you have the value of 255, which presents full radiation according to the sensor. So if you're looking into that MET file in this, you can see that you are having here some kind of attribute. So the dimension in the Y, the dimension in the X, and then you have here an attribute 0, long name, 8-bit signed, which is band to reflectance, and you have some kind of units, which is reflectance, and the valid range of the reflectance value is from minus 2,000 up to 16,000, which is the physical value of reflectance in the scene. So each point here has a reflectance value, which is given by 2,114 or 528, 996, and this is stretched to a value or gray value of 131 and 129. So we will adjust the gray value in a few minutes. So let's go back into the properties of this layer. So we were here. So there's no statistics calculated, and we have an extent which presents the visible extent according to the scene look, or the scene we can see here in the data view, and the full extent of the layer or the data frame. And you can have, or you will have, some display options. So contrast, you can adjust the contrast, so just make 80% maybe here, so you have a lot of more contrast, but we will leave that by 0 because actually some of you don't really know what contrast means. I will show you later. Then you have a brightness value and a transparency value, which is quite useful if you're using more than just one layer. So we will go with the 0 at the moment, and you can see the so let's go back to properties, and you have a symbology. Symbology is very useful by choosing a good color representation of your values. So for this case, grayish values are the best I think you can use, because the band number 7, it is just one band. I will show you later on how to calculate or how to create a raster data set which will show you the data in real colors. And as for the moment, use the grayish ones, especially by let us assume that you have some kind of topography layer, or we will just remove that layer. And as you can see, I have a topography layer which is called SRTM. I will just add that at the moment. So the projection system is, we could check that. Properties, just go on the source and check the projection system. As you can see, it's the same scene here, so all the same projection, UTM zone 48 north, and as you can see, just gray. So go back to that, go on symbology, and you can see that you have some kind of unique values, which is quite unuseful, because you have more or less a scale from 0, which is sea level, up to 9,000 or 8,800, and so you have a possibility of more than 8,000 colors. So you won't use unique values for that. So you have a classified possibility, so you can classify your data into several classes. Just make that. And as you can see, now you have, I don't know, 16 classes or something like that. And each pixel here is now represented by pixel value, which is the height above sea level, and the class value. So it's a 3rd class in our case, 5th class, 4th class, and here you have a 0 class. So, but height values represented by classes, I don't think that's so useful. So you have the stretch possibilities, and just by clicking on the color ramp, you can choose your color ramp. So some of my students think it's quite useful to make a very flashy one like this one, especially because you have a lot of possible colors in your data. But let's be honest, you already have used some kind of book where you have seen some maps, or you have used some topographic maps, so stay with them. Just use a color ramp which is informative for yourself, and where you can see, okay, green up to brown or grayish colors, so you have a representation of height which is more or less common. And I don't think that this color scheme is so common. You can also adjust the color scheme by clicking on the color table here, and then you have this little dialog over here. So quite useful color schemes are especially this color scheme, which goes from this very azure, I don't know the English term for that, up to white. I most like this color scheme over here. We will use this, and as you can see now, the lowest parts are represented in brown, which is unuseful or not common, so I will invert the color scheme, and now my higher values are represented in brown and my lower values are represented in this blue. But let's be honest, you cannot see anything, so we will concentrate on the problem of contrast now. So let's go back into the properties of this topographic or this height data. Go to properties, and you can see here in the symbology tab that you have some kind of labeling, so you can label your data, and choosing this slider will show you at first and a background value. So the background value in the 16-bit system is it depends on your data. So normally, or in most cases, it will be the lowest possible value in your data. But as you maybe have seen in the Landsat data, it was a value of minus 9,999. So I will now use minus 32,768, which is the lowest possible value, and just see what will happen. So as I have chosen this one as the display background value, there's no background available in the moment, so it is not shown on the map. It is shown as no color value. I can simply go along and choose the identify button in this border zone, so I still have the pixel value of minus 32,000. Let's go back into the properties. As you can see here, we have or this whole box over here is a contrast box. So you can have a contrast stretch and you can create your statistics. And let me just switch over to PowerPoint to show you what is contrast all about. So as you can see here, so let's go into presentation mode. You have something like an input value, which could be the gray, the digital numbers of your Landsat scene, the heights above sea level, or whatever. So I have a minimum value of 0 and a maximum value of 255. You can translate it easily to height values like 0 sea level up to 3,000 meters above sea level. So this is all the same. So this is the input data. This is your raster set, and you have a number of pixels. So how many pixels have the value of, let us assume, 120? How many pixels have 160? So as you can see here, we have a lot of pixels over here. They're concentrating on this small band of the whole available color scheme, and there are a few pixels over here that are concentrating on 0 up to, I don't know, on 180 or something like that. And when you're using contrast, or when you're using the term contrast, it describes the distribution of your pixel values. So you have a very small distribution, so you can say that it's small contrast. And this is your input data. So this is the raster data, and you have an output section over here. I've just changed this axis here. So you have an output section, which is a representation of on your screen, maybe. So if you're just making no attachment of or no arrangement of the contrast, the input data will be just converted to your output or to your screen contrast like this. So you have a line over here which will connect the 0 and the 255, so the maximum value of your possible bit system. So it depends on the bit system also. So in this case we have an 8-bit system. In the 16-bit system the maximum possible values was 32,000 something, and the lowest possible minus 32,000 something. And by using contrast, it means that you are connecting your something like your curve with this with this magic line over here, and just arranging or mirroring your curve to your output screen. So you still have a small contrast. So how can you increase your contrast in the scene? This works by changing this line. So we will go along and create a new mirroring line, maybe like this. So you have this area here, and then a bigger slope of that line. And if you're using the same system, so just connecting this point of the curve with a line and reprojecting it, you will get something like this. So we have this point here reconnecting, same length overall, same length, and in the last case this one connected to this point. If we are now connecting these mirrored points together, you will have something like this. So you have a much larger contrast, or much bigger contrast in the scene on your screen. So you have a better representation of your values, and you are not adjusting the input data. So you're not touching it. You will just arrange the look on it. So go back to ArcGIS, and I will show you how to arrange this. So we are not touching the data itself. So we're now just using the histograms. So we're pressing on the histogram. As you can see here, this is something like this curve I've shown you before. So there's a line. You have a possible maximum value of 255 in this, and this lowest value is here. And just by pressing one point on that line, you can see that the input data, which is represented as this gray, is transformed into another output data. So we will just make this at the moment. So we are making some kind of conversative shift, and what we will see in a moment, that these brownish colors, as our color scheme represents, will become more into the direction of this yellow, or maybe also green. So let us just try this at the moment. We will just adjust this contrast by clicking OK. Once again, click OK, and as you have seen, it becomes a little bit brightened. So go back into the properties again, go to this, and what we are doing now is we touching this, and we are trying to reach a full representation of the histogram. So as you can see here, we have the lowest possible value over here, and the highest still at the end of the layer. Just press OK, press übernehmen. I have the German version for that, sorry for that. And as you can see now, we have a very good representation of the topography as we may know it from our perspective in some books or something like that. So we have greenish colors for the lower areas and brownish colors for the higher areas. But what is the problem now in this case? As you can see, there's no differentiation in this whole area. So there are a lot of different heights. As you can see here, we have a height of 1414. There's 1378, and so on. But it is all represented by the same height. There's one. Yeah, I will show you maybe that, not at the moment. So we would like to get a full scaled color scheme in your area. So what we will do now, we'll just remove that layer and use the ArcToolbox. So press ArcToolbox, and there you have, or you should have, a tool called Data Management Tools. Just expand it. There you have the raster data, or the raster toolbox, and something called raster properties, and we will calculate statistics afterwards. So we will use calculate statistics. We have an input raster data set, which is our SRTM scene, and we will add and ignore value. So we would like to have the value minus 32,768 be ignored for all the way. So we will use that. Calculate statistics has ended. We will just click add data once more, use the SRTM scene, click add, and as you can see now, we still have the value of minus 32,000, but the statistics show us that there's that this is not part of the area. So we have a lowest possible value of 1031, which is more or less over here, and the second or an highest value of 3467, and we can differentiate the topography at the full scale. So let's go into detail here. So you have a very smooth color change from lightish light gray up to dark gray here, and by adjusting the color ramp back to the old color scheme, there's still a change in the color. So you can also play around, of course, by adjusting the color scheme, and now you have a very something like flower power color scheme over here, and you can just make some very bad examples for using a color scheme, but we will use the old color ramp. Maybe this one is also, no, this one is not that good. We will use that one. So you have the greenish colors for the lower parts of the scene and the brownish ones for the higher parts of the scene. So this is contrast and also height representation in your data. What I would like to show you now is some kind of application, like creating raster sets, especially when you're downloading Landsat data, and most of you guys maybe want to use that as a first step into raster processing in geoinformatics. We will go into that, and I would like to show you how to use it. So you more or less will begin with something like first band, second band, and so on. So we will adjust this, or I would like to show you these three ones. We'll just click add, and what you will now see is just gray. So there are three different layers in the scene. In the end, we will adjust the visibility of the scenes, and in the end we will calculate real colored satellite scene or something like that. So you now have the first band in the upper part, second band, and third band, and as I have said, you can adjust the colors, you can adjust the visibility of the bands. We will add maybe now the SATM scene. We will adjust the area. So now the SATM scene is beneath all the other layers, and just by making the other layers invisible, you can see your area now. And just go with the identify button, as I've shown you. So the all layers is used in the moment, so you can use this for getting an information about your scene. You can use the topmost layer. There's just only the SATM scene, so topmost layer is the topmost visible layer in the moment. Visible layers as well. Selectable layers, there are no selectable layers. Selectable layers are shapefiles or something like that, and we will go with all layers in a moment. So you can see here that there's a height of about 2000 meters above sea level, and it is represented by the value of 237 in the ETM Plus scene. So for the purpose of creation of a real scene or something like that, a real satellite image which is represented in real colors, we will use something called a layer stack or composite of these three layers. So the band number 1 is representing the blue color, the band number 2 is representing the concentration of green, and the third band is representing a concentration or reflection of red color. So we will use the toolbox, once again use the toolbox, and I've prepared it, sorry for that. So go back to the data management tools, the raster we have seen them here for the raster properties, the calculation of the raster statistics, and now we will use the raster processing toolbox. And there's this a function called composite bands. So what will it do? So it will make a stack or something like it will add these 3 layers to one scene. So go into detail, create composite bands, and as you can see here, you have input rasters. So it creates a single raster dataset from multiple bands, and can also create a raster dataset using only a subset of bands. So we'll use now our band number 1 has a first band, the band number 2 has a second, and the band number 3 as the third. And then you have an output raster, and we will adjust this output raster location. So as you can see, we have not adjusted our default geodatabase. So every time you will be conflicted with that default geodatabase. So we'll go into this is the ArcGIS tutorial folder, and we will create a layer stack. Please choose good names for that, so it's ETM plus, and the layers used are 1, 2, and 3, and this will be stored as a tiff image as all the other layers. So it's now tiff layer stack. Everything seems fine. We will just press OK, and it depends on your system. So normally it will probably show up in your layer section afterwards. I've arranged it that all the results of my toolbox actions will not be presented in the layer sections automatically. I have to add the data afterwards in a single process. So we will just wait here. Now 40% is ready, 63. It takes some time. Now we are ready, and we will just use that data. There's our layer stack ETM plus 1, 2, 3. It was taking some time due to the fact that I have a lot of layers in here. So I will just I will mark these 3 and say remove that place. And as you can see, let me explain where we are. So we are in central Mongolia, and as you can see here, we have some mountainous area here, and there are a lot of trees on the mountaintops, and then you have some kind of floodplain. There's a river meandering through that valley, and you have some salt lakes, and but there's a lot of bluish in it. So let us concentrate on the layer stack. As I have said, the band number 1 is representing the blue color in the scene, and in this view over here, the band number 1 is shown as red. So we have to adjust that by just clicking on the red color and say the red color is represented by band number 3. The green color is represented by band number 2, that is fine, but the blue color is represented by band number 1. And we are in central Mongolia, so there's a lot of steppe vegetation, and this is not very dense vegetated. So there should be, or it should be visible, a lot of soil, which is represented normally as some kind of brownish colors. And here we have it. So there is the steppe. Brownish colors. We are in the end of the growing season. So the scene was taken in August 2001. You have the floodplain, which is accompanied by greenish colors due to the dense vegetation in the floodplain, by grass and something like that. So you have the city of Kowloon here. You can easily see, and you have the tiny river going through the valley. And this is also represented by darkish colors, and not really by blue, but we will go to the lake in the upper part of the scene. There we are. nice lake, more or less blue up to dark. And we can also use the identify button in this case, so you are now having a composite information, like the red is given by the number 114, the green by 365, and the blue by 215. So due to this, you can easily see how the reflection in the scene is. Especially the salt lakes have a very high reflection of the light, and of course our lake is not reflecting so much, so we have low values here. So I hope this was quite understanding for you. I will present some more videos on using ArcGIS for raster calculation, for creation of slope values, and also for using Python as our script language to make automatical processing of raster and shape files. So thank you for the moment, and goodbye.